One, two, three, go. Right, hi everyone. This is another interview. So today I've got Mr. Martins Obi, who is currently pursuing a Ph.D. with Lafayette University. So, hi Martins,
Hello, Oz.
and
It's
how
really
are you
good to be
doing?
here. I'm
Yeah,
well, thank you.
all right, cool.
Thank you for having me.
All right, no worries. So this is part of my continuing series regarding, showcasing um, people like myself that look like me, black people,
No
just
worries.
to, give young black people some idea, some inclination that there are other career alternatives, and
Mhm.
just to, have black people who've kind of, pursuing that particular course to exhibit, that measure of success.
Yeah,
And my
yeah.
focus is more on the STEM elements. I think that's where we don't really have a lot of young black people.
Hmm.
So
Yeah.
to start off, talk us about, talk us through about you, what you were about, and what motivated you to pursue your current career path.
Okay. Yeah, okay. Again, thank you for having me. My name is Martins, like you've said before, Martins Obi. I'm currently pursuing my PhD in design for additive manufacturing here at Loughborough University in the United Kingdom. Uh, I have about 6 years of experience working as a mechanical design engineer in the oil and gas sector back in Nigeria. And so if you like, my career is kind of diverse a bit because my master's was in manufacturing systems and management. And now I'm doing design for additive manufacturing. Yeah. So my motivation for, pursuing this career path is, growing up, I've always been curious, on how processes come together to to bring about a product.
Hmm.
More like getting things from a high level of abstraction and bringing them into physical products that would be used to solve problems. In
Hmm.
other words, bringing solution to humanity, if you like. And
Yeah.
by using principles, of course, already developed engineering principles, guidelines, rules, how do we put all this together to bring about solutions to problems for humanity? So that was one of the reasons why I decided to study mechanical engineering for my bachelor's degree. I mean, at the time, the school I attended didn't offer product design or manufacturing as a course, so mechanical was the closest, and I went for it. And I mean, it's been a very good journey. It's been a very rewarding one, if you like. Yeah. So.
All right, cool. That's nice to know. Um, so let's go back to the very beginning. So, what
Mm.
inspired you to, pursue engineering?
Yeah, like I said, in engineering is life.
Mm,
I mean, that's how I want to see it.
mm,
Engineering is life. For me, I didn't think, and I'm really going to be honest with you, I didn't really think I was really good to study engineering in the beginning. But I knew that I could read. I knew that I was curious enough,
mhm,
to ask questions and to try to find answers to those questions. So, people would always say, oh, engineering is difficult. And
mm,
I mean, the average black man would always say that engineering is difficult. Engineering is
mm,
difficult because you have a lot of physics, a lot of mathematics, you know. But for me, I knew that even if I felt in my mind that I wasn't good enough, but I knew that I could answer questions. I knew that I could ask questions and read to answer them. So that
mhm,
was a motivation that I had. I mean, at the very least. So, having that in mind, it was a motivation for me. And I moved on. I was able to conquer the challenges that,
mhm,
at that point that I faced. So one of the motivations as well, like I said earlier, is the fact that, I want to proffer solutions. Right. I want to profile solutions. And you can't do this without engineering. I don't know, somehow that's how I see it. Engineering, like engineering is life. I mean, even the human makeup, the human is engineering. So there's a lot of precision going on. You have your 2 ears, they have to be at specific places. If not, it's not accurate. So engineering is about its life itself. So for me, that was the motivation. And
because you said, engineering is something you want to do, but why mechanical engineering specifically? Why not civil engineering? Why not biomedical engineering?
So like I said earlier, it was, for me, I was very curious about how processes would come together to bring about products which would serve as a solution to a problem for humanity. But then I would have wanted to do something in manufacturing, engineering. But then the school I attended at the time didn't offer manufacturing as a course. So the closest was mechanical. I had to go do mechanical. But then my master's, I went, I was able to, pursue my dream, into manufacturing. And then I'm doing something in manufacturing, my PhD as well.
Okay. All right. That's cool. So before you went into university to pursue mechanical engineering, what were the subjects that you had to study to enable you be accepted to study mechanical engineering?
Yes, I had to be proficient in mathematics. I had to know physics. I had to know chemistry. At least these were the core. Then I had to add, biology was also very important, at the time. I had to be proficient in computer science as a course, as a subject. Then there were other, these were the core, these were the very, very core subjects. But then there were other subjects that I needed to also pass to enable me to be admitted into mechanical engineering bachelor's degree program.
Okay. Yeah. And in terms of your university journey, what were the subjects that you really enjoyed?
Wow, it's been a long time now, but I really enjoyed thermodynamics, fluid mechanics, production planning and control. I loved that because, of course, I'm a process person, so I love anything that has to do with manufacturing. So it was. These were the courses I did right back then in my undergrad, and then at the master's level, it was manufacturing engineering. As a module, manufacturing systems engineering as a module. It was also, I liked a bit of management because, as you progress on your journey, you need to know how to manage resources. And, manufacturing is about bringing resources together, machines, the raw materials, everything, bringing them to make the product. So you have to understand, you have to have at least a basic knowledge of management, how to manage resources. So I also enjoyed that a bit. Yeah. And, I became an enthusiast of additive manufacturing, which is a layer by layer manufacturing process. It's different from the subtractive and formative processes that we have. So these, I became an enthusiast, because it was something that was coming up at the time. And so I started to start looking into it. I became very curious. Oh, what's this about? Why is everyone tending to this direction? So I started to study on my own about it. And I decided, I'm going to do something around it for my PhD. And here we are today.
Okay. All right. Nice to know. Cheers for sharing that. Okay. So let's come to, after you finish university, you go into industry. So talk us a bit through in terms of your career journey.
Yes.
Before you started to, pursue your master's, what were you doing?
Yeah. Okay. So before my master's, I was engaged with a company, Saipem. It's an international firm. The headquarters is in Italy. So what they do, they are an EPC company in engineering, procurement, and construction.
Okay.
So I was, for about 5 years, I was engaged in a project for Shell. So what I did was I was in the role of a specialist engineer for static equipment. So I oversaw the design of pressure vessels, storage tanks, heat exchangers, air coolers, and these static equipment that are used. Another static equipment that are used in a plant. So it was for the project was a greenfield project. So it was a project from the scratch, and we had to design everything from the scratch. Thankfully now it's running. It's a gas plant actually. Now it's running now. Yeah, because I left them a long time ago. So, but now we've got to report that it's running. Yeah. So after that, I came for my master's. And after my master's, I went back to Nigeria to take up a senior mechanical engineering role with NETCO. NETCO is the National Engineering Technology Company of Nigeria. But it's called NETCO, sorry. But it's the engineering arm of NNPC, Nigerian National Petroleum Corporation. So that was where I worked for about 9 months before I came to the UK for my master's.
Okay.
For my PhD, sorry.
For your PhD. Okay.
Yeah.
So if I understand it correctly, you did your master's with Cranfield University. Am I right?
Yes, please.
Okay.
Yes.
All right. Cool. So you went to pursue manufacturing. All right. So in terms of undertaking your master's here in the UK, what were the differences in terms of your education experience in Nigeria and your first education experience in the UK? What are some of the key differences that you noticed?
Yeah, to be honest, there were a lot of differences. There's a lot. So let me start from the very basics. First of all is the curriculum, what they are really taught, what the contents of the modules. So you could see in the UK, and I'll be very frank. Please allow me to be very frank.
Be frank. Be honest.
So it's in the UK you have these practical based modules where hands-on students are hands-on. They if you say we are designing, if we want to have something designed, a product designed, you actually teach students to design the product. And one of the learning outcomes of the module would be that the students would actually design and report how they have designed the product. So there will be a physical artifact or product, whatever, that would be submitted, or a portfolio, if you like, as we want to. But yeah. So, but then, back then, when I don't know, I'm sure things have changed. It's been about 12 years since I finished undergrad, but back then it used to be, we are taught the process, but then we are not given the opportunity to, develop this product, right, to implement it. So that's the difference. So somebody who actually implements it has a deeper understanding. The person is learning by doing. So the person comes out better than the one who knows the theory and has not applied the theory, to develop the product, if that makes sense. So that's on one part. Then, secondly, was about for me, there was culture shock. That was my first time of coming to the UK. Trying to understand how things are done, how people behave, and that's on the surface, anyways. Yeah. But another thing now I want to point out is the confidence that students have. How students are trained to be confident, and I think it also has to do with the level of knowledge that they have gathered over the years, if you like. So somebody who actually knows how to do something, who doesn't just know the process, but knows a person can actually, if there's a mouse here, this mouse, I can design it and I can get it manufactured using every manufacturing process that there is. So the person is very confident. And you see that lecturer-student relationship, where the student is not a subject. You get, the student is treated as a client. Okay. To a certain level, because the student has a say. Within the ambience of, morality and, good behavior, and if you like. So, but the students can actually be expressive. They can actually tell you what they feel It's not right. I mean, the first time I had my, it's funny, but the first time I had my module while I came to the UK, it was operations management. And after the module, the module leader came. The person who delivered the module was even the module leader. So the guy came into the hall and shared what's it called now? A feedback form. And I'm like, really? I'm like, really? Right. Share the feedback form in the class. Oh, you have to fill this because we want to know where we would improve. Well, things we have not done well, so that people who will be teaching next year, there will be an opportunity to improve on the services that we provide. And for me, it blew my mind. I was like, okay, this is something new for me, because where we're coming from, unfortunately, these things do not happen. So the teacher is the Lord of Lords, is the King of Kings. and no, but I mean, this is the truth. So it became, I started to think, oh yeah, this might actually be nice. And for me, the things I really didn't like, I had to state them. It was my friend. I was really happy doing that. So yeah, and so that teacher student lecturer student relationship is there. You find students having personal tutors. You find students being mentored. Back home, these things don't happen. So, I mean, just let me not go too deep, but I mean, these are the things I actually noticed. These are the things that I actually noticed that could actually impact on the students, and help them become better. Yeah. Let's leave it at this. Maybe as we go further,
No, don't worry. I mean, this is a platform where you can freely express yourself, so don't worry about it. Because again, without criticism, you don't really find that way of improving things. So
yeah,
just be honest, because we're all here to learn. We're all here to, explore, how the other side, does things. All right, so that's good. All right, so you finished your masters, and you moved back to Nigeria. You worked with the Netco. Then you decided to, pursue your PhD. So why Loughborough, and why additive manufacturing? Why designing for additive manufacturing?
Okay. Where do I start now? There are a lot of stories around this, but I'll be very frank. I really want to be very frank. I just knew I've always wanted to have a PhD. As a young man who was growing up, I'd always told myself that I was going to have a PhD. And I told myself that I wasn't going to pay for my PhD. So I was very intentional about what I wanted. And because I was intentional about what I wanted, I worked hard towards them. It wasn't easy. It wasn't easy. It's a story I would love to share some other time. It wasn't easy at all. But, having that, the mind travels first. When you close your eyes, you visualize where you want to be and how you want to be. Then the mind travels, and your physical being, your mental, your mind, you begin to develop yourself to get to that point where your mind is. For example, I've said that I wanted a PhD. To get a PhD, you need to understand how to write a research proposal. You need to understand how to even do research. So while I was doing my master's, I knew that I was going to, head on to do a PhD. So I started learning some of these things. I started attending some lectures, some like tutorials that are organized by some very wonderful Black people. So they just came together and they felt, oh, we need to start telling people about research. So I was attending, I was knowing, I started to know how these things are done. So that helped me a lot. So why Loughborough? It was Loughborough because, or it is Loughborough because of the topic. So the topic was actually what drew me to Loughborough. So when I saw design for additive manufacturing, don't forget that, when I answered the previous question, I said, I mentioned that I became an enthusiast, an additive manufacturing enthusiast. So, and I wanted to do my PhD on anything around additive manufacturing because I knew that it's the future. of is trying to revolutionize what manufacturing is, at least for now. We have not gotten there, but for now, right? So it was because of when I saw the opening. Oh, I didn't even know Love Pro, to be honest. It was that topic that made me contact my supervisor, and he said, "Oh, okay, let's talk about this." And that was how it came to be. But then being in Loughborough has been a blessing to me. You know, it's been, I didn't even know that it's one of the best schools in the UK. But I'm not very keen about those things. But I mean, coming here, I realized, oh, you're one of the best schools in the UK. That also gladdened my heart, you know, and it's pushing me to do more. So yeah.
Okay. All right.
Hope I answered the question.
Yeah, you have. Well, cheers for that. All right. So you talked about additive manufacturing. So when was the first instance or your first time of getting into, the world of additive manufacturing?
So it was during my master's.
Okay.
So during my master's, so when I came to the UK, of course, I started seeing, I visited some labs at Cranfield. They're also big on additive manufacturing as well. And I started to see, what's, away from the subtractive and conventional manufacturing processes. I started to see that we could actually print things and not have them in pieces. We can have everything printed together. And we don't weld, we don't rivet, we don't use injection molding. We just print. So I was fascinated, as a young man. I mean, as somebody who has seen where all these other things were happening, right? So it was interesting to me. So that was how. So when eventually I chose a topic for my master's final year project, so I decided it wasn't part of the scope. So, but I decided, and I told my supervisor that, I would really want to try using additive manufacturing, because I developed a demonstrator for seamless welding of PVC floors for a company, Outro. So I said, okay, let's try to see if we can print some part of the demonstrator with additive manufacturing. And that was my first time. And he said, oh, why not? But make sure that when you print it, you test it, make sure that it can withstand the load, because it's a demonstrator. So that was how I was able to do that. That was my first experience with it. And so I think what really led me to design for additive manufacturing was the fact that I couldn't get funding for actual additive manufacturing projects, if that makes sense. So, but because of my experience with design, coming from a mechanical design background, so my professors thought, you could be a very good candidate for this project. So that was how the twist now came. Yeah.
Okay. All right. Cheers, Martin, for that.
Yeah.
All right. So let's now explore your current journey through your PhD. So how was the first year? What were some of the challenges that you encountered in the first year? So you're now in this new environment, this new location that's it's a small town, not like London or Birmingham.
Yeah.
And so what were some of the the things that you found interesting and challenging at the same time in the first year of study?
Okay. Okay. So I'm married and I have a very beautiful family, but unfortunately at that time they were not here with me. So
Yeah.
it was one of the challenges I faced in my first year. My wife was working in Nigeria and she wanted to really finish up the project she was doing before she came over. So it was a bit of challenge for me staying without them. But then, you find these challenges everywhere. And I would really want to be specific because I'm a person of color. So I understand that there are challenges that I still face because of who I am. So people don't get to see what you can bring to the table. They just look at you from a distance and think that you are not, you're not capable of doing stuff. So at that time, I needed to prove a point, right? And somebody asked the question, why would you hire somebody from Nigeria? Somebody was asking my supervisor, why would you all the way hire somebody from Nigeria, pay higher school fees? Of course, because our fees is higher than the local students.
Yeah.
Pay higher fees. You do stuff. You also have to pay him stipends. So why would you have to do that? So I needed to prove a point. It was challenging. Sometimes I would be here till 11 at night, trying to make sure that what I was doing was worth it. So trying to make sure that, I'm doing a PhD, at that first instance, you are swimming in an ocean because you want to know everything, which is not possible. It goes like the double diamond. So you first expand it, then before you come. So it's really at that time it was difficult from being alone as a married man and trying to also prove a point with what I'm doing. And I'm thankful that I did, because it's all paying off now. It's I have one of my paper is published, the other one has passed the review stage, and we just have to make some changes by May and it will get published again. I've spoken at conferences. I have papers submitted to conferences already. So these things are the outcome of the hard work of that first year. So I mean, there were challenges, but then in the long run, they're paying off.
Okay. All right. Cheers, Martin. All right. So just give us a little bit of an insight in terms of studying as a PhD student. What does it entail?
Yeah, studying as a PhD student, to be honest, and thank you for this question, because it's something people really need. I mean, the young, not really young, anyone who wants to study for a PhD. I think, first of all, it's about you wanting to actually do a PhD. So you have to. So anyone who comes to me and says, "Oh," I tell them, I say, "Do you really want to do a PhD? Do you really want to do a PhD?" I say, "Yes." "Okay, why do you want to do a PhD? Is it because you want to be called a doctor?" Or
Why not?
I mean, but yeah, that's true. But is it because you want that that title, or do you want to make a difference? What's your reason? So you have to be convinced that this is a path that you want to go on. You have to be convinced, and that conviction brings about the willpower. That conviction brings about the willpower. So because you are convinced, then you, regardless of whatever challenges you face, you'll be up to it or up to them. So it builds your confidence, to face challenges. So studying as a PhD student, first of all, like I said, you need to really want to do a PhD. Secondly, you should be able to read. You should be able to read. To read. Reading is a problem. I mean, the young people, I'm saying this from experience, because at some point I have had the opportunity of speaking to a few young people. They really don't want to read. And you can't know if you don't read. You have to pick up something and read it. Just read. It's when you read, the eyes of your understanding will be enlightened, if that makes sense.
Yeah, it does.
Yeah, you begin to know things differently. You begin to understand how people say things differently. When you read well, you will know how to write, because what you have read would impact on the things that you will produce and how you will produce them. So you need to be able to see that. You need to be independent in your thoughts. So you need to sit down and say, you see this is where I want to go. This is the path I want to do. And in doing this, how do I achieve the end goal? So you have to be independent. I'm not saying you won't make mistakes. You would make mistakes. And that's why you have the supervisors and the committee, whoever, to put you through. But you have to be independent. You have to start showing that you have the capability to be independent in your thoughts. Studying as a PhD student is you also have to live a balanced life. I wouldn't want to be too, let me just make sure that I touch every aspect. You have to ensure that you live a balanced life. In my first year, it was so much. I mean, because I was this at some point I broke down because I'm the kind of guy that I play badminton. I'm the kind of guy that I love to run. I love to go to the gym. I love to do so many things. But I never did those activities in the first year because I wanted to prove a point. And because my family was not here. Maybe if my family was here, maybe it would have been a different issue. But I broke down. So it is important that you live a balanced life. Try to create networks, networks of people that would inspire you to do things differently. Right. I don't know if I'm touching everything, but I mean, these are the few points from the top of my head.
No worries, because I mean there will be other opportunities to probably do a Q&A, particularly for people who are interested in pursuing a PhD, particularly anything relating to STEM. So that's nice. So at this part, I'll just let you touch on some of your research area or your area of interest in terms of what you're pursuing for your PhD. So you're focusing on design for manufacturing. So in a nutshell, what is design for additive manufacturing all about?
Yeah, thank you very much. So when we talk about, let's start from additive manufacturing. Additive manufacturing has been the buzz. Everyone wants to print. No one wants to use injection molding anymore. And the rest of them, people want to they want to use the technology, but it's like they've gone so far and they've now looked, but this technology is costing us a lot of money. The use of this technology is costing a lot of money in terms of the material, the process. And so something that normally would be manufactured using the conventional manufacturing process. So why would I want to use additive manufacturing when it's going to be of the same cost, if you like? So technology should bring about cost reduction. I mean, that's an ideal situation. So they've taken that huge step, but now everyone is going back to think, now, how do we begin to exploit the advantages, the potentials, as I call them, the potentials that additive manufacturing offers? Now, let me just say a bit of this potential. So, I mean, from research perspective, you have them in terms of there are four major complexities that additive manufacturing tries to explore: the hierarchical complexity, functional complexity, the material complexity, and the shape complexity. So in terms of the hierarchical complexity, you talk about how do we start making lightweight by removing materials where they are not needed, right? Redesigning solid domains into lattice structure, try to incorporate things like meso, micro structures into our design. I don't know if this is a bit technical, but I don't know if the simplest way to say it. So then the functional complexity, how do we start bringing in features like integrating features into our design that are functional? So how do we start looking at part consolidation? So you get a lot of different part. You get a component with different parts, but then you can print them and they become a unit. So that saves a lot of costs, right? So how do we now, in terms of shape complexity, how do we start, manufacturing products with various complex shapes that are aesthetically appealing and would also be functional, to provide, to carry out its duties, or to perform whatever it's produced for. Then in terms of the so that was the first one, the material complexity. So how do we then start using digital materials, multi-materials? These are capabilities that have been offered by additive manufacturing. But then until you are able to design for additive manufacturing, you cannot use these potentials. You cannot address them. You cannot incorporate them into whatever product you're trying to manufacture or you're trying to print. And that is the reason why design for additive manufacturing is gaining so much traction than additive manufacturing itself, Right. So because if it's the printing, people know how to print. The workflow is there. By the time you get your card, card design, you turn it to STL file, you take it to a slicing software, you put on get the process parameters, you send it into the printer, post processing. That's the more like the workflow on the skeletal.
Yeah.
Yeah. So but people know these things, but then how do you actually get the advantage? How do you exploit the potentials of additive manufacturing? So that's what my research is about. So there's a lot of knowledge that has been developed. A lot of knowledge. For me, and as somebody who has spent some time in industry, and I'll say this from experience, because one of the jobs that I did, I mean, in getting into my job, it's funny to say this, but I actually, somebody who had 7 years of experience resigned from that position, and I was brought in to replace him. So you can imagine the gap between both of us, between the knowledge. So, but if SciPem didn't have a system that was able to disseminate this knowledge, it would have been even much more difficult for me. So that's what my PhD is about. How do we disseminate this knowledge? How do novice designers grow to become experts? Because we don't have time. We don't have time. There's no time. We don't have time. The technology is there. The technology is evolving every day. New processes are being developed. There is one a stereolithography, it's a fast polymerization process that is being developed in Nottingham University. So, but how do we exploit the knowledge? So that's what my PhD is about. And to this point, I'm trying to develop tools that would enable us, to undertake to exploit this potential. So that's what my PhD is about. So that was just a background on, yeah. I hope it's
yeah. Cheers for that. So in terms of what you're actually undertaking in terms of design for additive manufacturing, is it something that's more generic that can be applied across, different range of materials from polymers to metals? Or is it just limited to, looking at polymeric processing?
So the idea is that it's going to be generic. And the thing is that when you design for I don't know, when people say you design for SLS, you design for maybe laser sinter, you design for FDM, you design.
Yeah.
I don't think
Or that polymerization.
I don't think that's proper. Designing for additive manufacturing is design for additive manufacturing, regardless of the process. So if you can make a lattice structure, the only difference might be the materials and the way the process is carried out. But then if you want to get a lattice structure in FDM, you can get it with sinter, you can get vast polymerization. You can do all that. So it's across board. But for us is that designers will be able, whether engineering designers, whether industrial designers, product designers, they will be able to understand what these potentials are and how they can use them in designing for additive manufacturing.
But surely doesn't the measure of tolerance play a factor in terms of the processes? Because
it does.
Because some processes will give you, tighter tolerances to others. So, for instance, your fuse deposition, comparing that to, let's say, vat polarization. Vat polarization will give you, number one, better resolution, and two, much more of a tighter tolerance compared to, your fuse deposition modeling. So, does your research cover those elements?
Yeah. So the thing is, these are for each. There's a process-specific rules. So there are rules, principles, guidelines, right? So they are process-specific, but they do not affect the fact that if I want to take out material from this point, right? If I want to make sure that this is lightweight, it doesn't affect the fact that I want to design a complex product. So this, you see, they are on two different levels. So if you like, in my research, what I have called the rules, guidelines, specific tools, those are the specifics, because you use them to achieve the complexities, you use them to tackle the limitations, and they also give you a very in-depth knowledge of the process itself. So because they are process specific. Right. So on that level, on that high level, we are talking about how to deal with the complexities first of all. Then using these specifics, which are particular to the processes, if you like. So I don't think we would say we design for fuse deposition modeling, but I would also always just say that we use the rules for design for FDM, or to achieve complexities, to deal with these complexities.
Right. All right. Cheers, Martin, for sharing all that information. I'm very certain that anyone that watches this that's into using 3D printer will find this quite insightful. So, in terms of the phase of your PhD, because at the moment you are kind of like in the final stages of your PhD.
Yeah.
So, what elements did you cover and complete in the first year, and likewise in the second year? If you could just give us a brief summary of that.
Yeah. Okay. So, of course, in the first year when you come in, you would have to do a literature review. So you have to understand what is going on in the field. What knowledge has been developed, what has been done. For me, this differs. Why I'm saying this is because for some people, their topic is already defined, is predefined. For me, it wasn't that. So I needed to think about what I would do. So I needed to go deep into the literature to understand what has been done and what has not been done. So for me, I used the bibliometric analysis method to X-ray the research that has been done in the field. And this is the paper that I spoke about that would be published soon. That actually gave rise to that paper. So I used the bibliometric analysis to understand. I did a scoping review. That was how I got these knowledge classifications. So I realized that this is missing. There's a missing link between what is known and what is not known, and that's what I'm trying to address. So in my second year, in my first year as well, apart from doing the literature review, I also focused on understanding what designers know. So because before you can be able to disseminate knowledge, you need to know what do they know, and where are the aspects that need further development. So I used a quantitative analysis, a quantitative research method to, using an online survey to understand, and about 201 participants were able to respond. And we found out that, materials is one of the things that people are really, material complexity, they are not aware because it is evolving. And I think one of the issues is that the individualistic nature of these processes, they need individual materials to function, if that makes sense. So FDM, you use the different material, use a different material for vacuumization, a different material for laser sintering, and the rest of them. So it's just different. And powder-based fusion as well. So you use a different material for those. So it's different. So that's an area where more research needs to be conducted. So I did that in my first year. That's also going to be published very soon. My second year, I started to, COVID came in. COVID hit us so bad in the second year. So in my second year, I was able to do another study. So now I wanted to understand, really, I was curious to ask, okay, since we know what they know, we understand what designers know. Now, how have they learned what they know? And how would they want to learn in the future? Let's not forget that additive manufacturing is the sophistication around additive manufacturing and the processes brings about new way of thinking, brings about new way of doing things. So let's really understand what we used to have in the past. Is it what we're going to have in the future? And I used another the same process, the same research method, and I asked designers. It was interesting because the the result that came out of that study was interesting. Normally, with the usual, I say the word conventional design, I don't want to say that, but you know what I mean when I talk about those who do not design for additive manufacturing. Okay. What usually how they would learn, of course, would be because there's been extant knowledge. Some knowledge has always been there for ages, and there's no uncertainties. There are no everything is known. So you're using for example, you're using a design precedence. You know this is a house that's been designed before. I can use features in this house for inspiration to design another house. But in additive manufacturing, it's not so. Right. So the results that came out of that study was that the people want to learn from experts. It was. I mean, they want to learn from colleagues and experts. And I was like, okay, how do I proceed with this? How do I proceed with it? But then, and you know, I also tried to do to understand if the years of experience of the designers also mattered. I tried to understand if their years of design practice. I tried to understand if their area of design expertise. I tried to understand if I think there's another factor I can't remember now. So there are three factors that I tried to check how they would impact on how designers want to learn. But all came out the same, and they said that we want to learn from experts, especially when it comes to additive manufacturing. And that's because there's been even the experts themselves want to learn from
other experts.
Yeah. So because there's no knowledge base available. There's nothing people can fall back and say, oh, we've done this before. It's been proven, you know, we've done this and it's good. We can commercialize it. We can. It's not. I mean, it's evolving, but we're not there yet. So people don't want to take the risk, and so that's why it's important that we ask these questions. So going forward, I've also engaged in. I mean, at the end of last year, coming into this year, I've engaged with experts, you know, to find out. You know, sometimes online surveys are really not. You have to go, you know, interview these people to try to understand the reasons why they have said what they said, and they give their various reasons, and which has been reported as well. So in this year, I'm looking at an intelligent online mentoring system, because that is one of the ways. Apprenticeship is another way, but it's not what we're looking at this time. So we're looking at an online intelligent online mentoring system for designing for additive manufacturing. So that's where I am now, and that's the last phase of the PhD. So once that is done, specifications will be produced for that, and a framework as well on how that will be run.
Okay.
So,
all right, cool. Cheers for sharing that. So hopefully you get everything wrapped up sometime later this year or early next year. So. Right,
hopefully next year.
Hopefully next year. Okay.
Yeah.
All right. So, what happens after PhD? What are your plans after PhD? Do you go back into industry? Do you go into academia? What's the plan?
People ask us this question. People have asked me this question a lot, but so I to be honest, I don't want to go back to industry.
Okay.
Yeah, I don't want to go back to industry, and I've always known that even if I continued in industry, I would someday become. I'll be in the classroom someday.
Yeah, be an academic.
I'll be an academic. Yeah, that's the. I'll be an academic someday.
Okay.
And so why not start now? Why wait till you are, why wait till you are 50, 60, and 70 before you get? So why not start now? So I mean, and I know in doing the PhD as well, I'm trying to tick most of the boxes. To get to that point where you are seen as somebody who can actually lecture, especially here in the UK. There's a lot of experience you should have gathered over the years. So I engage in teaching, which you are aware about, and I also try. At this semester, I'm also doing another teaching for design for additive manufacturing, digital fabrication skills.
Okay.
So
that's just the part C's.
No, it's for the master students.
Oh, for the master students. Okay.
Yes. So I've just been incorporated into that last week.
Okay,
So
cool. So that's
yeah,
under whose module? Is it under
Abe,
Abby? Okay,
and
Patterson.
Patrick, my supervisor. So he
Okay,
just brought me, oh, Martins, come, let's do this. And I'm like, okay, no
okay.
problems. Yeah, so it's held 3 hours every week, and I think it's fair. So yeah, so that's what I'm doing. Publishing papers as well, attending conferences, so that the boxes that you need to seek, trying to apply for grants, which I'm trying to do now. I don't know
Yeah.
if that is going to work, but well,
Well,
sometimes
you
these
never
things, you
know.
just have to do it,
You have
just do
to,
it,
because I think that's
Yeah.
one of the things that if you have a PhD and you're thinking about becoming an academic, particularly in the UK HE
Mm,
sector, your
mm,
capability of securing funding is very important. So you do need to
yeah, yeah,
demonstrate having, some form of portfolio that evidence that.
yeah, yeah,
All right, cool. What
yeah.
about, because you're now saying that, okay, you're having a bit of a taster in terms of, teaching. So what are the things that has come as a revelation, being in the classroom? Like, let's say the very first time that you stepped into the classroom.
Also, this.
No, I just want to see. I just want to know from your perspective.
Okay, yeah. Well, to be honest, yeah, it was different for me. It was different for me. It was, and well, I would say that our backgrounds really matter a lot. Sorry, let me deviate a bit, and I'll come back to the question.
Okay.
So that the kind of background you have really matters a lot. It does matter. It contributes to building your confidence.
Mm.
You know, you need to have certain exposure, because the people you're trying to teach are people who over the years have been exposed to various things, and you need to be on that level where you can be able to deliver.
Mm-hmm.
Right. So, for me, I thought it was the usual stuff, the graduate stuff. So I just came and I was and when they threw me some questions, it was, I was like, okay, I didn't think about this before coming to class, and all that. So I mean, I was supporting all this module, in the first semester. That was, I think, last year, 2 years ago. It was last year.
With
No, it was 2 years ago,
COVID,
September of 2 years ago.
yeah, 2 years
Yeah,
ago, yeah. Because
yeah,
with
2 years
COVID
ago.
going on, to be very honest, I've lost track of time.
Oh my
So
goodness!
yeah,
So
I'm kind of like,
it was September 2 years ago. It was in my first year,
yeah,
it was the end of my first year. So yeah, I mean, it was different for me, and it's been a journey of self-discovery as well. It's been a journey of, I go back home and I say, oh, Martin, should have made this mistake. Why did you, talking to myself, learning from my mistakes, and which is very important as well. And, seeing myself as somebody who is going to be one of the finest lecturers that would ever be, because of my experience. Yeah,
I like that.
no,
I
yeah,
like
no, I
that. That's
mean,
good.
yeah, because you learn, you grow. As you learn, you grow.
Yeah.
You become more confident.
Mm.
You learn. I mean, and this is not just me saying this because of an interview. When I look at old teach, I'm like, oh my god, when would I be like this? So I also go back and say, he does it this way, I need to do it this way. He does it this way, I need to do it this way. He answers questions this way, I need to do it. So I mean, you learn. You just you
Yeah.
learn. So that's how it's been for me, actually.
Oh, okay. So which parts are you enjoying? Which part of the team do you enjoy? Is it more the one-to-one bits in terms of like tutorials? Is it more to do with lecturing, so to say?
So I've started mostly. I mean, in this my PhD. I mean, I've started teaching mostly in tutorial classes. So I think, like, I could do any of those, but progressively, if you like.
Yeah.
So I'm currently undergoing the rotor scheme, where part of the things I'm trying to deal with is my delivery.
Yeah.
So my delivery, and so it's a process for me. But I really enjoy one-to-one, because it gives me the ability to express myself.
Yeah.
And because I love to have one-to-one conversations, so
Yeah.
I can it's easy for me to do that. But I mean, as a lecturer, you should have the ability to, to handle a whole hall filled with students. And that's where I'm looking to get to, with all this. Yeah.
Okay, that's cool. That's cool. So yeah, so hopefully, you get into, the academics, and hopefully you establish yourself there. So at least
Yeah.
that's good. That's nice to know. So in terms of anyone that wants to, pursue, let's say, engineering,
Mhm.
design, what are the type of soft skills that you believe they need to have, other than, having the fundamentals in some form of STEM subject? In terms of
Mm.
interpersonal skills, what type of
Mm.
skills would you encourage, prospective learners going into the field of engineering or design? What should they have?
Mm. Okay, yeah, that's a very good question because most people think it's about being technical. They think it's about, well, let's put the drawings, let's design it and let it. No, you need to understand how to work in a team.
Mm,
You need to team playing ability is something that employers. I mean, even apart from coming to the university, employers it's a skill that they actually want to see in a prospective employee.
mm,
So they want to understand how you're able to blend in a team, how you're able to give a helping hand, how you're able to also receive help when you're giving, and how you're able to ask for help, when you are stuck. So how you're able to be the best, contribute
mm.
efficiently in a team. Then you also have to, you need to know how to communicate.
Yeah.
Design, you need to know how to communicate. And there's technical communication. I always encourage people to, how do you break down what you're doing so that even the person who is not in your field is able to understand what you're saying? How this sort of things, how you're able to communicate both orally and verbally. Sorry, orally and in written, right? So it's very important. You have to be organized as well. These are soft skills. You have to know how to prioritize your work. You have to know how to, I mean, you can be an engineer working in 3 different projects. At some point when I was working at Saipem, I had that. You're supporting different projects. They ask you to do certain things in certain projects. So how do you prioritize? How do you, draw your Gantt chart to know which activity comes first and which you should give priority to. So these are the things that are really, really important. They are soft skills, and you should just understand how to be professional as well. These are,
Mm,
professionalism, poise and professionalism, they are key. How to carry yourself. These are soft skills. People don't teach you how to do these things. How do you carry yourself in an organization that when people whenever there is something to, who would represent us, not just because you are intelligent, but say, oh, he can actually do that. She can actually do that. Aside from the fact that he or she is intelligent, but they have the appearance, they have the courage, they have the poise. So these are the
yeah.
things that you need to look at. I mean, at least with this, if you add all these to the technical skills, then I think you'll be a good match, or you'll be a very good hire in any company.
Mm. All right. Thank you for sharing that,
Yeah. Okay.
Martins. Okay, so I think at this part I'll wrap things up. I mean, you're a very busy person. I mean, you you actually on campus doing work, so kudos for that. To be fair, I don't even remember the last time I even went back to campus.
Uh,
It's been a while. Yeah, it has been a while. I think last year.
have you been to campus this year?
No, I don't think so. No, I haven't. No, I
Okay.
have. I have in the early stages. Yeah, I have.
Hmm.
Okay. All right. So I think this will conclude this segment. As I stated, there will be further opportunities for us to, probably do once the project starts kicking off and I start
Hmm.
getting subscribers. Maybe we could, organize, um, provide an opportunity for Q&A where,
Hmm.
particularly anyone that wants to like pursue a PhD to get deeper in
Hmm.
sense of what it's
Hmm.
about. It's not just about, you know, writing exams and automatically you
Hmm.
get your doctorate. There's more to it than that. And
Hmm.
there's certain soft skills that you need to have to enable you, progress over 3 years in achieving, your PhD. So hopefully, when things do kick off, there will be to probably do that.
Yeah.
Right. So final parting words. So what would be your advice to, any young person who wishes to go into engineering or go into, let's say, product design?
Yeah, I mean, okay, if you're looking to start start a career now, if you're looking to study, let's put it at that, what is study engineering and product design, then you should be convinced that you should be, there has to be a conviction that this is what I want to do. And you have to see yourself as somebody who is coming to profile solutions. Because I think if you don't, I think it should be that way, because whatever you study should be applied.
Yeah.
It should be applied. There should be an application of whatever knowledge that you've gathered, So you look at that and read. Read. It is very important. See, to be honest, let me say this, and I want to say this. You can be more than you ever think you can be. You can. All it takes is just, you sitting down, paying the price of taking the textbook, or surfing the net to get information. You can read and know, understand, and apply. You can be more than you can ever think. So, I mean, this is not just for anyone at all. I mean, anyone who wants to do anything. So just put that at the back of your mind. Mathematics is not difficult. Mathematics is the easiest, I think, in my because it's very objective.
In your humble opinion.
Truth, in my opinion, because it's very objective, right? This is truth. So when they say truth, this is truth. You can only find truth in mathematics, because 1 + 1, you can't. Yeah, I don't know if you can actually say it's not 2. Somebody might say it's 11, but I don't know. but my point is that these are the things. There are things that you need to know. So you just sit down. You don't think that you can't do them. You can actually do them, and even more. So see yourself as somebody who wants to go into the world to provide solutions to problems. And you see, when you get, I mean, when I was in the UK, when we got the first gas at the site where I worked, and they sent me the message where they fired up the pressure vessels, and and all that. And I was happy, because these were the things that came from our thoughts, and they became reality, and they are used now, to solve problems. Right. So it's that kind of thing. It's those kind of things that you need to put on your mind when you are, when you want to go into engineering or product design. So you can be more than you can ever think you can. You just need to sit down and pay the price. See yourself as that. See yourself as that product designer, and that will propel you to do more.
All right. Thank you very much.
Yeah. So before you conclude, we are in our design for additive manufacturing. So we are developing a network. I'm currently working with my supervisor, though it's in the UK for now, but there's a possibility of extending to international candidates very soon. So it's what we are doing, and in this we have a lot of events that we are organizing. Now we are looking at a poster competition. At this time, which I'm privileged to be the chair of that event. So going forward in the future, we would want to extend it to international students. So please just watch out, and it's an opportunity for you to have contact with some of these people. I mean, people who are in the UK, and see how things are done, and take it up from there as well.
Yeah, because I'll be right now. 3D printed is coming. It's really progressing in Africa. Parts of Africa.
Yes.
So I think today I was watching CNN. They've got this kind of spotlights on the continent, and you can really see a lot of people really get into it, to the point where you've got individuals building their own 3D printers. So at least that tells you that the the skill is there. That
It's
level of
there.
imagination is there. It's just
Yeah.
stuff that needs to be tapped, honed, and encouraged. So
Yeah.
yeah, okay,
Exactly.
that's good. All right,
Exactly.
Martin. So cheers for those words of wisdom. I'll let you be for now. I mean, you're already looking knackered after having spoken for a couple of minutes. So
Yeah.
yeah, so I'll let you be. So cheers for those final words of wisdom, and hopefully anyone that watches this will at least be inspired. If they want to pursue number one, anything relating to what you're doing in terms of
Mhm.
the uh, subjects under the STEM umbrella, and
Mhm.
people that are desiring to maybe pursue a PhD. So as I
Mm.
stated, we'll see how it goes to maybe one day organize a Q&A, live Q&A event where we can have,
Yeah.
um, discussions and provide responses to, anyone that's curious about pursuing a PhD, what that entails, what type of skills do they require, things like
Mhm.
that, and maybe some
Yeah.
insight into, what the world of design for additive manufacturing is all about.
Yeah.
So
Yeah.
thank you very much,
Thank you.
Martin, and hopefully we can do this some other time.
Yeah. Thank you for having me.
All
Thank you.
right. All right. Cheers.
Yeah. Cheers. Bye.
All right. Bye.